There is a wall system that snaps together from massive foam and wood panels, goes up weather-tight in days, and outperforms a normal wall so badly that a federal lab had to double-check its own numbers. It can survive a Miami hurricane. It has been sitting right there in the American Building Code since 2007, and one of the first ones ever built was dedicated by a sitting First Lady back in 1937, then outlived her by decades. It is called a structural insulated panel. It works. It is legal. And almost nobody builds with it. So why did the toughest, tightest way to frame a house never catch on? And why does getting one approved still feel like sneaking something past the rules? Here is why this matters to you. You are living inside the most expensive housing market in generations, in a country that is millions of homes short of what it needs. And the way we build hasn't really changed in a century. A crew still shows up, cuts hundreds of individual boards, nails them together one at a time out in the weather, and hopes it all lines up. It's slow, it's wasteful, and the wall it leaves behind bleeds heat in ways almost nobody notices. There has been a better option the whole time. Rewind to the Great Depression. In 1935, engineers at the Forest Products Laboratory in Madison, Wisconsin were trying to solve a real problem. America was chewing through its forests and they needed to build more using less wood. Their answer was strange for the era. What if the skin of the wall carried the weight, instead of a skeleton of studs underneath it? What if you could skip the frame entirely? By 1937, they had a working test house made of these stressed skin panels, and it turned enough heads that Eleanor Roosevelt showed up to dedicate it. Here's the detail that says everything. That little house survived brutal Wisconsin winters and stayed in use as a daycare center until 1998. 60 years, still doing the job. At the same time, one of the most famous architects alive was tinkering with the same idea. Frank Lloyd Wright used early sandwich panels in his Usonian homes. Problem was, his panels barely insulated anything. Enter Alden B. Dow, a student of Wright's and conveniently the son of the man who founded Dow Chemical. He looked at those coal panels and asked the obvious question, what if you filled the middle with foam? In 1952, he built the first true foam core panel, and that's the real birth of the version we use today. The oil crisis of the 70s got builders paying attention again, and by the 80s, oriented strand board arrived and the modern panel was complete. This isn't some infomercial gimmick. It's pushing a century old, it came out of a government lab, and it has Frank Lloyd Wright's fingerprints on it. So why is it still treated like the exception? To answer that, you need the physics, because the physics is the whole story. Think of a steel I-beam. It's strong because of its shape. Two flanges take the load. A thin web between them keeps them from buckling. A panel is that same idea turned into a wall. The outer faces are strand board acting as the flanges. The foam core between them is the web. Stand it up, and it just holds. No army of studs required. Here's the part nobody thinks about, and it's why your heating bill is higher than it should be. In a normal wall, insulation only fills the gaps between studs. The studs themselves barely insulate at all. Wood conducts heat straight through from warm inside to cold outside at every single stud. That's called thermal bridging, and it can cut a wall's real performance nearly in half. Your insulation might be rated great, but the framing is quietly leaking heat in vertical stripes across your whole house. A panel has no studs. The foam runs edge to edge with nothing interrupting it. Then there's air. This one surprises people most. Up to 40% of a home's heating and cooling loss isn't through the walls at all. It's air sneaking through gaps around the framing and wiring and windows. Fiberglass does almost nothing to stop moving air. A panel wall is a sealed shell, no cavities for air to travel through. Oak Ridge National Laboratory tested this directly. They built two identical homes, one paneled, one conventionally framed, and ran blower door tests to measure leakiness. The panel home came out as much as 15 times tighter, but the bigger bombshell is what Oak Ridge called whole wall R-value, testing an entire real wall, studs, seams, windows, and all, instead of a clean insulation sample in a lab. A 4-inch panel wall rated R14 beat a 2x6 wall stuffed with R19 fiberglass. The lower number won, because the higher number on the conventional wall was fiction that ignored its own studs. Bump up to a 6-inch panel and you're looking at roughly R21 against R11 for the wood wall. Nearly double. What does that mean on your power bill? Take a real documented case near Green Bay, Wisconsin, a 3,500 square foot panel home. An energy evaluation showed annual savings of $3,265 over an equivalent stick-built house. That's $272 a month staying in someone's pocket instead of floating up the chimney. Across the industry, typical savings run 40 to 60% compared to conventional construction. Now, you clicked on this expecting a house that heats for free, and I'm not going to pretend that's true. What is true is that when you wrap a house in a continuous, sealed, high-performance shell like this and pair it with solar or geothermal, you can shrink the load so far that some of these homes get close to net zero. The wall doesn't make power. It just needs so little that making the rest yourself becomes realistic. That's the honest version, and it's more impressive than the myth anyway. As for speed, panels are cut at the factory to your exact house before they ever arrive, windows and wiring channels included. A small structure can go up in a day. A full house shell goes up weather-tight in days, not weeks, using as little as 3 to 5% of its material as framing lumber versus 22 to 24% for a standard frame. And it's tough. That same I-beam rigidity that carries a roof also resists the forces that tear houses apart. These panels are approved for Miami-Dade's hurricane standards and certified across every seismic zone on the books, including the worst earthquake country on the West Coast. You've already met the durability proof. That 1937 house lasted 60 winters and was still working when they finally tore it down. So here's the paradox. Faster to build, cheaper to run. Engineered for hurricanes and earthquakes, born in a federal lab refined by the Dow family used by Frank Lloyd Wright, legal in the National Code since 2007, and still, almost every new American home goes up exactly the way it did 100 years ago. Something is holding this back, and it isn't the technology. Open the building code, and you'll find panels listed, section R610. But look at how it's written. Wood framing is the baseline, the default everything else has to measure up to. Panels get in as the guest, not the host. That single choice tells every inspector, lender, and builder in the country which method is normal. Your inspector has seen 10,000 stick walls and maybe 2 panel walls, so a panel job means unfamiliarity. And in high wind or seismic zones, an engineer's stamp you'll have to pay for. Your lender wants something easy to resell, meaning something that looks like the house next door. And then there's the appraiser, the quiet killer who values your home by comparing it to nearby recent sales. If no panel homes have sold nearby, there's nothing to compare it to. In one real case, a Florida city built panel homes for an affordable housing program, and the appraiser had 0 panel sales to reference, so those better built homes got valued as if they were ordinary stick houses, simply because that was the only data available. Add in an entire supply chain, mills, insulation makers, framing crews, all built to serve the stick frame method, and you get an industry with every incentive to keep the default exactly where it sits. Nobody has to ban the better idea. They just let old momentum carry on by default forever. So is it actually illegal? No. It's written directly into the code as the structural equal of the wall your neighbor is standing behind right now. What feels illegal is everything around the permit. The inspector's hesitation, the engineer's fee, the lender's raised eyebrow, the appraiser with nothing to compare it to. None of that is a law against you. It's friction. 1,000 small frictions stacked up to feel like a wall. And unlike a law, friction is something you can plan around. Should you build one? Depends. High wind or seismic country. Budget for that engineer's stamp from day one. Your builder matters more than the panels do. A crew unfamiliar with the system will fumble it and eat your savings. Because the shell is so airtight, you need mechanical ventilation. That's not optional. It's a health requirement. The foam needs a fire barrier, usually just standard drywall. And moisture detailing has to be done right or trapped humidity becomes a problem. None of that is a deal breaker. It's just homework. If you're actually considering this, here is where to start. Get a quote from a panel manufacturer based on your real plans. Call your local building department and confirm they've adopted the code section and ask what they need to approve one. Ask for the manufacturer's third-party evaluation report. A serious company will have one ready. If you're in hurricane or earthquake country, line up your engineer early. look into federal energy tax credits plus whatever your state and utility offer. And when it's time to appraise or sell, hand that appraiser the energy data and certifications yourself instead of letting them guess. If it still feels like a leap, start small, a workshop or a garage, and let that be your proof. Because this was never really about foam and wood, it's about how the better version of something can lose for decades, not because it failed, but because the world had already organized itself around whatever came first. The panel didn't vanish. It's been sitting in plain sight the whole time, in the code, in the science, in a little house a first lady dedicated almost 90 years ago, waiting for enough people to notice that normal is a choice, not a law. If you want more of this, cutting bills, building tougher, leaning less on the grid, subscribing is how the next one finds you.